On assignment 1, problem 14 is talking about rolling some dice. So in this case, it's saying Yahtzee is when you roll 5 dice that have 6 sides. So the typical die, which has 6 faces. I'm going to do a problem that is similar. Instead of doing the exact problem that you have here, which is 5 dice that have 6 sides, I'm going to say I'm going to roll 6 dice that have 5 sides. Okay, so make sure that you realize that my answers here are obviously not the answers that you put into your assignment problem. I am solving a question where I am rolling 6 dice that are 5 sided, and you are trying to solve something that is 5 dice that are 6 sided. So make sure that you make the changes and don't just simply put in the answers that I have got. That won't get you the correct way to do this. So here, again, if you are going to use some of the techniques on the computer, then then I would make sure, if I was you, that I would watch the video in problem 11, because I'm not going to go through how to calculate these terms by hand or by R in this particular video. So if I wanted to then roll 6 5-sided dice, not 5 6-sided dice, and I wanted to see what's the probability that when I roll these 6 dice, at least 2 of them have the same number showing. There's a lot of ways to calculate this. Okay, so here I am going to start by saying what's the probability that exactly 2 of the dice show the same number. And then I'm going to do the probability of exactly 3 of the dice show the same number. And then exactly 4, exactly 5, and finally all 6. And then I can add those probabilities together. So here, first thing I need to do is imagine what the dice could show. So each dice has 5 options, and there are 6 of them. So here, if 2 of the dice were going to show the same thing as each other, and then the other 4 dice show something different than what the matching pair was, and different from each of the other remaining dice, then I would have 2 that are the same, then 1, 2, 3, and 4 dice that have all different numbers from everyone else. So here I've got exactly 5 options, 5-sided dice to choose from, and I've got 1 double and 1, 2, 3, 4 singles. So 1 double and 4 singles. So I can break it up like that. I do know that these 2 numbers must add to this number here. In this case, it does, so that's great. Then I just have to worry about order, because the dice that match don't have to be the first and second dice. It could have been the first dice that fell and the fourth dice that fell that were the match. So here, as far as order goes, out of the 6 dice, you've got 2 of them that will act as a block, and then every other one acting as a single. So 6, 2, 1, 1, 1, and 1. So here again, we'll make sure that the part in the bottom will add to get what this number here is. So if you want to calculate these numbers and you don't know how, then I would recommend that you go and watch the video in problem 11. Now, another way that you could see 2 dice have the same number is that exactly 2 of the dice have the same number as each other. There's another 2 dice that also have the same number as each other, but not the same as the first 2 dice that have the same number. And then 2 dice that have neither the option showing of the first 2 pairs, nor does it show the same option of the last die. So in here, I've got 5 options to choose from. You can see that there are 2 doubles. Okay, so AA and BB, that is 2 sets of doubles. And then here I've got 1, 2 singles as well. So I've got 2 doubles, 2 singles, and then I have to include this last number so that here this bottom row will add to get me the 5. And then as far as order goes, I've got 6 dice. These 2 are a block, that are the A's. These 2 are a block, that are the B's. Then I have a C and a D to talk about the different orders that these could fall, because they don't have to do AA, BB, C, D. It could have been AC, A, B, B, D, for example, would be another ordering of the same kind. The other option that I possibly have then for having 2 dice show this to have the same number is you've got 2 dice that show the same number as each other, 2 more dice that have the same number as each other, but not the same number as the first group. And then the last two dice also showing the same number, but that is not the same number of the second pair or the first pair. So here I've got exactly 3 sets of doubles, 0 singles, and therefore I need to have this 2 number that will add to get to this 5. And then as it goes down to ordering, I've got out of the 6 die, 3 blocks of 2. So 6, 2, 2, and 2. Okay, so if I add all these together and then divide the denominator where you have all 6 die having exactly 5 options, which would be 5 times 5 times 5 times 5, all the way to 5 to the 6th power. This would be the probability then of seeing 2 die have the same number, either in only 1 pair and everyone else is singles, in 2 pairs and everything else is singles, or in 3 pairs. Okay, if I want 3 of the dice to show the same as each other, I've got a triple and then singles, I've got a triple, a double, and then a single, or I've got 2 triples. And again, using the same sort of logic here, I've got 5 options. One of them is a triple. I've got 0 doubles, but I do have 3 singles, and then I need to make sure this adds to 5. And then as far as blocks out of this 6, I've got a block of 3, and then I've got 3 singles. Here, out of the 5 options, I've got a triple, 1 triple, I've got 1 double, and I've got 1 single. And then I need to make sure this adds to 5. Out of the 6, I've got a block of 3, a block of 2, and then just a single. And finally here, out of the 5 options, I have 2 triples. Okay, A's and B's are both triples. I've got 0 doubles, I've got 0 singles, and then here I need to add to 5. And finally here, out of the 6, I've got a block of 3 and a block of 3. So these would be the number of ways, and then when you divide it by 5 to the power 6, you will get the probability. What about the probability of getting 4 of the dice to show the same number as each other? Either 4 show the same and then the other 2 show different numbers, or 4 show the same and then the other 2 show the same number as each other. So here out of the 5 options, I do have 1 set of quads, 0 sets of triples, 0 sets of doubles. I just left those zeros out, but I do have 2 singles. So 1 plus 2, and then here an additional 2 will add to 5. And then out of the 6, I've got a group of 4, and then 2 singles. And here, if I have 4 that are the same and then a double, then here I've got 1 quadruple, I've got 0 triples, and I've got 1 double, I've got 0 singles, and so I've got 1 quad and 1 double, and then here a 3 will add to 5. And here, as far as ordering goes, I've got 6 die and a block of 4 and a block of 2. This will get me the number of ways that I can have 4 of the dice showing the same number. What about 5 of the dice showing the same number? Okay, so out of the 5 options, I've got 1 set here of quint. I've got 0 triples, so I've got 0 quads, I've got 0 doubles, and then I just have 1 single. So here, this is the 1 quintuple, this is the 1 single, and then adding to get to 5. And then out of the 6, I've got a block of 5 and a block of 1. What about all 6 die showing the same number? Okay, so here I've got 5 options, and then here I've got the 1 set of all 6, as well as a number that will add to 1 to get to 5, which would be 4. And then as blocks go, there is only 1 block here. So out of the 6, all 6 of them are blocked that way. Okay, so that would be the probability of getting any of these individual 1, 2, 3, and so forth number of dice showing each other. Okay, so what about here when the question gets to like part C or part B, when you're talking about rolling a run or a straight? What that means is numbers that are sequential. The order doesn't have to be. So here I'm saying, let's change things to say, I am now rolling only 3 dice, not 6, or sorry, yeah. So originally up here I was rolling 6 dice. Now, just to make things a little bit smaller, I'm going to say, what if you're rolling only 3 dice, but each of the dice has 5 options? Okay, so how do I get a run? Well, a run would be the numbers 1, 2, or 3, the numbers 2, 3, or 4, or the numbers 3, 4, or 5. Now notice, although these are sequential numbers, if you had 3 dice and you got the 3 first, and then you got the 1 second, and then you got the 2 third, that would still be a straight. So although we are looking for 3 sequential numbers to be a run, you do not have to get them in order. Okay, so here, I put a 3 out here. I'm multiplying by 3 because there are exactly 3 types of straight. A 1, 2, 3, a 2, 3, 4, or a 3, 4, 5. There are only 5 options, so I can't go up to 6. So here I've got 3 types of straight. Okay, so how do I get any particular straight? Notice that the chance of getting a 1 is 1 out of 5 because there's only one out of 5 options. The chance of getting a 2 is also 1 out of 5. There's only one 2 of the there's only one 2 out of the 5 options, and the chance of getting a 3 out of the 5 options would be 1 out of 5 as well. So regardless, any specific number you're talking about has a 1 in 5 chance of being selected. So here, when you're saying what's the chance of rolling a 4, well, if there are 5 options, there's only one 4, and so that would be 1 out of 5 chance to roll a 4. Okay, so here, no matter what, if you're looking for a particular number, then the chance is 1 out of 5. So I'm looking particularly in this case for a 1, a 2, and a 3. So each of those has a 1/5 chance, and if I multiply 1/5 times 1/5 times 1/5, I will get 1/5 to the power 3. Finally, the last thing that I need to do is realize that I can get these numbers out of order, but it still count. Like I said, for example, if you rolled the first die and got a 3, and then you roll the second die and got a 1, and then you roll the third die and got a 2, that would still count as a straight, even if you didn't get it in the order of 1, 2, 3. Okay, so here, this is where I am talking about that I know that there are 3 elements to any of my particular straights, and because they are not the same as each other, they are all individual. So this is going to be a 3 ways that this could happen, and then I just need to individually get that there's no ties, there's no whatever. So it's 3 with a 1, 3 with a 1, and 3 with a 1. Okay, if you calculate this out, it's going to end up being 3 factorial. So here I've got 3 different types of straight. I've got the probability of any particular number happening. And so here that's 1/5 times 1/5 times 1/5. Then I've got the order happening there. So here in this case, if I was rolling 3 die that all had 5 options, the options being 1 through 5, then the chance of getting a straight would be 3 times 3 factorial over 5 to the power 3. This is a very similar, here I've got the answer right there. Let me just delete that for a second. Here, if you're observing a straight when you've got 5 6-sided die, then you're going to have to use the same techniques here, but think it through for the new pattern. Okay, and good luck.